So basically, what is the purpose of eMobility System Lab? We provide the skills, industrial skills to the college freshers, those who are not aware about the actual skill set which are required by the industries. Hello. So basically, there are a lot of institutes
Yes, sir.
like, so they take more charges, more fees, which is not affordable for the student sometime. Got it. And a part of it, the students, after paying so much money, the people are not able to get such knowledge which is actually required by the industries. Okay, so I have worked in electrical vehicle domain, into the in the R&D department, research and development department. Okay, so we provide embedded system related courses, or embedded system related skill set, along with electrical vehicle side like charger, EV charging systems, and battery management systems understanding, and also hands-on experience on the industrial projects. Okay, got it. Any doubt?
Yes, sir.
कोई doubt अभी? Like any doubt or any question you want to ask? Anyone? So this is my WhatsApp number. Okay, and basically this is 3 month to 4 month classes, and mostly on the Saturday and Sunday, or sometime we take classes on the Friday as well. Okay, if I feel like any topic is pending, or I need to deliver more extra knowledge, so accordingly I adjust the class. So according to that I adjust the classes. The all the classes would be remote classes. Okay, so you can take it from anywhere. These are the flexible classes. Generally we take classes in the evening. So basically we will focus on STM32 microcontroller. Okay, so this is ARM Cortex M4 processor, M processor. So there are a number of series in the M processor. Okay, like M3, M4, M7, M9. So all whatever processor you are using, it depends on your application. Okay, so this is totally depend on your application. So and what are the, and if we talk about STM32 microcontroller, so this is highly used in industrial industries, automations, and IoT applications as well. In EV charging systems we are using STM32 microcontroller. In most of the industries are using STM32. Okay, and this is high demand. This STM32 and ESP32 is into the high demand basically. Okay, so STM Electronics is a company which has developed this STM board. And what are the peripherals of STM32 microcontroller? These are the GPIO, general purpose input and output peripheral, timers, ADC, UART, I2C, SPI, CAN, DMA, and PWM. Okay, so we will work on all the peripherals of STM32 microcontroller as we will move forward. So this is the board. So this kind of boards you can purchase from the market. Okay, so this center is part your MCU. Got it. So basically in industry we call microcontroller is MCU. What we call MCU. Got it. So MCU is microcontroller unit. So this is my MCU part. And so here is basically a debugger section, programmer. Okay, ST-Link debugger we are using, or ST-Link programmer we are using. ST-Link, and this part will be connected with your PC. Okay, and through this you will flash your code here. Okay, so basically whenever you are flashing your code, so you have to flash your code in the flash memory of your microcontrollers. So there are different kind of memories in the microcontrollers. Okay, so what is we flash our code basically ROM, in ROM. Okay, so this is a permanent memory or a non-volatile memory. Got it. Non-volatile memory, and this is or we can call it permanent memory. Okay, and so here we flash our code. Okay, got it. So this side you are able to see these are the pin sections. Okay, so these are the pins. These are the pins basically. Okay, so when you will purchase your board, so this is the development board. It is a Nucleo board. So the pin section will be displayed like this. Okay, so you will be able to understand these are the pin header pins, or these are the pins, these are the port pins basically, na? So GPIO port has different pins. Timers, there would be separate pins for the timer, there would be separate pins for ADC, separate pins for every peripheral of the microcontroller. Got it? Hello Nikita,
Yes, sir.
any doubt?
Yes, sir.
Any doubt? Have you seen this kind of nucleo board? Yes. Kabya,
No, sir.
have you seen?
No, sir.
Okay, so this board is used in the industries. Okay, so guys, we will make the class more interactive. So if you have any doubt, any questions, so you can ask me, so that I will take more interest in teaching to you. Understood? Kabya, you can ask me anything, whatever you have doubt.
Okay, sir.
Okay, so until we will not we will talk, then we will not understand anything. Na? I want people who can who should question properly or ask the doubts. Shall we move forward now?
Yes, sir.
So let's take an example of GPIO. Okay, so you will see this is the application. So here are basically these are the layers, or you can say, okay, so GPIO pins can be configured as input pin, or can be configured as output pin. Okay, understood? So when
Yes, sir.
you are configuring your GPIO pin as input, then what is the meaning of this? And when you are configuring GPIO pin as output, what is the purpose? Why we are doing this kind of things? Anyone can tell me? Nikita, you can tell. Yes. Be louder. Actually, I'm not able to hear you.
I don't know about that, sir.
Why? So this is a very basic part, na? Ki you should understand the states of the pins. Okay. So suppose this is your pin, okay, GPIO pin, and it has two states. Which one? Input and output. Okay. So these are basically modes. We can say not states, or we can say as a modes. Okay, input. Either we can configure GPIO as input or output. Or if we talk about states. So what are the states of GPIO pin? 0, 1 and Z, high G state. So there are three states of GPIO pin. So one is low, another is high. Okay, and third is high G, floating. So this third stage is called as a floating state. Floating. So we don't want this floating state. Understood? Okay, so here you are able to see na कि सबसे पहले, like initially what we will do, we will set the pin as a input or output. Okay, so accordingly we will write the logic high or low. Okay, so suppose you want to blink an LED. So what mode you will select? Input or output mode? What mode you will select when you want to blink an LED? Anyone can tell? Hello?
Hello, sir. We want to select input.
No. So suppose you want to blink LED. So this is your LED. Okay, this is your LED, and you want to blink. For this, you have to supply some voltage. Okay, you have to supply some voltage na, to this pin. Kabya? So
Yes, sir.
how will you get this voltage from the pin, na, GPIO pin?
Sir.
So this pin will supply this voltage to LED. Okay, suppose this LED blink, this LED need 3.3 voltage. Okay, so this pin will give 3.3 voltage. GPIO pin will give 3.3 voltage na? And this voltage will go into the LED, and LED will blink. Okay, so what you understood from here? Like you got some voltage on GPIO pin na? So you have to make this state high. Okay, so what is the meaning of high state? High state means you are getting some voltage on GPIO pin, suppose 3.3. Okay, you want to off LED. Okay, so you want to off it. So what voltage you need on GPIO pin? Hello, would you try to tell me?
Sir, 0 volt.
Okay, so 0 volt you need. Okay, so how will you get this 0 volt?
Oh,
Pin na?
pin. Yes, sir. We have to set the pin.
We have to control the pin na? Like from the firmware or code. Okay, So we have flashed our firmware or our code into the microcontrollers. Okay, so microcontroller is controlling this voltage. Sometime it is giving, or it is providing 3.3 voltage on pin. So when the pin will get 3.3 voltage, then in this case LED will blink. Okay, and after 1 second the pin voltage will be 0, then LED will be off. So you want,
Yes, sir.
so it depends on you na, ki you want LED on, you want LED on, okay, for how many minutes? Suppose you want LED all the time, okay, all the time, or you want LED in a blinking state, or in a high state, okay, for 3 minutes, 4 minutes. Got it? Now we have
Yes.
taken 1 second. Okay, so for 1 minute, for 1 second the LED will blink, and for after 1 second LED will be off. Got it? On and off we are doing. Understood? So
Yes, sir.
what we are doing here, we are changing the GPIO pin state from high to low, low to high, high to low, low to high, after every 1 second. Understood this one? So you guys, you should know how to play with the modes of GPIO pin, how to set the modes of GPIO pin, and how to play with the states of GPIO pin, high and low. Okay, got it? So here you are able to see na, ki you are writing high, then LED will be on. You are writing low, then LED will be off, and we will use some delay. Got it?
Yes, sir.
Any doubt here?
No, sir.
So if you have doubt, so ask me now. Suppose you are making the pin mode as a output mode. Okay, so you want some output from the pin, okay, LED kind of things. And suppose you want input mode, then you have to attach some sensors. Okay, so both modes will have different purpose, different applications. So you want to sense the temperature value, you want to connect some sensors in the GPIO pin. So then GPIO pin will be configured as input. Okay, understood na? So when you are configuring a GPIO pin as input, so you are reading some temperature value, for example, and you are reading the sensors value, any kind of sensor it may be, and the value of sensor you are sending to the microprocessor. Okay, input means you are sending some inside of the MCU or processor, or output means you are sending something out of the processor. Got it? Hello?
Yes, sir.
Okay, so let's move forward now. So here you are able to see, let's take the cursor here now. So this will give you more understanding about the layers, or about how the things are working actually. So lowermost layer is called GPIO controllers. So this is basically a hardware part inside the microcontrollers. Okay, and this is on SoC level, system on chip level, and after that this GPIO controller is connected to the driver layer. So this is the layer basically na? This is the GPIO controller is connecting or communicating with a driver layer. Okay, and then a driver layer is communicating or connected with a GPIO chip. Okay, and then GPIO chip is connected to the user layer, application layer. So where we will write the code here na? This is user layer. Who are the users? Programmer is a user na? So this layer is called application layer. So generally this part is handled by the manufacturer, those who are providing the microcontroller board or development board or microcontrollers. So you don't need to worry about this part, this section, this complete section, but I'm giving you more insight about the things, how the things work actually inside, or okay, inside the microcontrollers. Sometime drivers we can generate, or we can write the drivers as well. Okay, so, and sometime the company provide you the driver, you need to configure the pins only. Got it?
Yes, sir.
Okay, so did you understand this part, application layer? So you will write code here na, in application layer part. Okay, so we will also see how we can write the drivers, how we can generate the drivers automatically. Got it? So this, okay, so without driver layer this application layer will not work. Okay, so drivers, there are separate drivers for different peripherals of the microcontrollers. Okay, so there are different drivers for the CAN, there are different drivers for the UART, SPI, I2C. Okay, so you always understand, you should understand the drivers are the important parts. Without driver, your peripheral will not work. Okay. Okay, so this is the internal architecture of GPIO pin, how the GPIO pin work actually. Okay, so you will understand here, like this is the output data registers. So inside the microcontroller, GPIO pins are basically connected to the registers. Okay, output data register and input data registers. Got it. So when you want to write something, when you want to make your pin high, okay, so you have to enable this register, you have to work with output registers. Okay, and there are two kind of transistors here, and PMOS and NMOS. Okay, hello. So do you understand
Yes,
about
sir.
the transistors basically? Okay. So I see, I tell you how the state transition, how the GPIO pins states are changing actually, na? Sometime you are making your pin high or making pin low, so this is happening just because of this transistor part. Okay, so when you are making your pin high, then this transistor will be active. Okay, and you will get some voltage on the GPIO pin. Okay, so sometime you see the GPIO pin state is low, there is a 0 volt on GPIO pin, so this transistor will be off and this transistor will be on, and this will connect your GPIO pin to the ground. Okay, so this will connect GPIO pin to the ground. Okay, so when you want to write something, when you want to you have writing, you have written code here, and this the data will send into the register part, and from here it will go here this way, and output control unit here, and so in this way the GPIO pin works actually. So similarly, so if we see upper section, okay, so upper section you want to configure GPIO pin as an input pin, so this input data register will be in a working state. So now there is no need of this register. Okay, and we don't need this transistor as well, so we will focus here actually. Got it. So suppose you have connected some sensor on the GPIO pin, so the sensor value will go like this, and sensor value will store in this input data register, and from here after input data register the value will go into the processor. So suppose this is your processor. Okay, got it, na? So how the switching happening on the GPIO pin? So basically this part is controlling the switching of GPIO pin. Okay, so from here you are getting the signals like this, or you can also configure GPIO pin as a alternate function input mode as well. So this section is output driver, and this section is input drivers. Okay, what is the purpose of input driver? If you understood well, what is the purpose of input driver? Hello, hello, anyone will tell me? Hello,
Hello, sir.
would you tell me like how many members in the meeting right now?
3 members.
Who is
Four,
uh,
four
b-
members.
so guys, you are not able to speak anything, I'm speaking only, like how will I get to know that you are understanding? You you until you have no confidence, how will you get crack the interviews? So this is also a processor part, na? Will you speak? Like if you are making any mistake, then
Yes,
it's
sir.
okay, but you should speak at least, na?
Yes.
I
Yes,
want
sir.
I want develop the confidence in you.
Yes, sir. Actually, I was finding it difficult, sir. I was not understanding this the input driver and output driver, why it is there. So
See,
that's why I did not.
see, why drivers? What is the purpose of drivers in the general life? Na? Driver basically it drives something. Okay, like suppose there is a vehicle driver. Okay, so vehicle driver will drive the vehicle. Understood, na? Car
Yes,
driver
sir.
will drive the car, and GPIO
Got
GPIO driver will drive the GPIO pin, na? So drive
Yes.
GPIO pin driving doesn't mean like it is going somewhere else. Someone is sitting inside the GPIO pin and okay, it is taking GPIO pin somewhere else. So it will, you have to understand the states. So GPIO pins states are changing na, input and output.
Okay.
So you have to understand there is something you have to play around the data. Okay, data is the main part. What is the data? What we can say, what is the what is the meaning of data? So data is the information na? I said now you have to blink the LED. So you have to play or you have to switch the states of the GPIO pin na? Input or output. Got it?
Yes, sir.
So who will handle this driver part? So let's move back. So this is the driver layer na? So
Yes, sir.
this code, this is actually a code written in C, embedded C. Okay, so this code will handle the input and output driver of the GPIO pin.
Okay.
Okay, so for now you have to understand this GPIO pin internally connected with the registers. Okay, and there are two kind of registers, input register and output registers. Okay, so what is the meaning of register? Registers are the units which store some values. These are the kind of memories. Okay, okay, so now let's see this part. Mm. So when you will program your microcontroller, you have to install the cube STM32 cube MX. Okay, so the interface of software will look like this. Okay, so here you are able to see pinout configuration section. So pinout configuration part, you will get system core, you will get analog, timers, connectivity, multimedia, security, so multiple things you will get here. Okay, so accordingly here are the clock configurations, system clock. Okay, so you can do the clock configuration from here. Got it? So once when you will open or when you will install, you will select your development board. So this interface will open in front of you. Okay, so here you are able to see the multiple pins. Got it na? Multiple pins here. So
Yes, sir.
P and multiple ports. So what is the meaning of PA? So basically there are the ports. Okay, so PA means like pin, port A. Okay, and port A, pin number 5 or 6. Got it?
Yes,
So
sir.
suppose you want to connect LED here on this pin. So you have to right click on this pin and you will change the state of this pin as a output pin, output mode. Okay, got it? And you will click here, the section is given basically generate code. So after configuration is done, then we will click on generate code. So it will automatically generate the drivers related to your peripheral. Okay, so let's see one example how the code is written, how this project will work actually. Okay, so are you able to see this LED is blinking? Okay, so this LED is connected on PA6, port A, pin number 6. Understood? Again, so who is handling the blinking of this microcontroller? This STM32 na, this microcontroller is handling the on and off state of this LED. Hmm? Okay, so here you have to add some libraries in the code. Okay, so library, why we add the libraries? Basically libraries have multiple or functions which are highly used in the program. So our code will start from int main. Okay, and then we will use curly bracket, and we will write this hell initialization. So this thing will automatically be generated by the STMQID. Okay, you don't need to write this line. Got it? So what is the purpose of hell abstraction layer? So in STM32 there are two kinds of coding actually, or so you can write the code in two ways. Number first is bare metal programming. There are two kinds of programming actually. So you can write the code in bare metal, and you can write the code in hell abstraction layer. So this HAL is simple as compared to the bare metal. Okay, and after hell initialization we have to configure the clocks. Without clock your microcontroller will not work, so you have to configure the clocks. and we will see in the upcoming sessions or workshop what is the purpose of clock configurations, how we can do the clock configurations as well. And after that clock configuration is done, clock is properly set, then GPIO port or we have to initialize. Okay, so why we are initializing the GPIO? Hello, hello, will you speak louder slightly? I'm not able to hear you what you are saying.
Yes, sir.
Why we need to initialize a GPIO pin, GPIO port basically, na?
To consider the electrical behavior, sir.
Mm-hmm. So see, yeah, that is correct. But we are working on the GPIO port, na? So our basically LED pin is connected to the GPIO. Okay, so we have to initialize the GPIO port. Otherwise, the pin will not work. So we have to write the code inside the while loop. Okay, because we want our work in a continuous way, na? Every 5 second, every 500 millisecond, we want to toggle the LED. So this is the function actually. Okay, so this is the function which is handling the toggling of GPIO pin. So which pin, like this is handling the toggling of GPIO pin number 5. Okay, so this is the correct way to write the function, to write the code for the GPIO pin. Okay, so this is the function which is already inside the libraries. Okay, or which has already been added in the driver layers of GPIO. So we have given some delay, so this function is handling the delay part. Okay, the timings actually. So here you are able to see okay, so here you are able to see, so every 500 millisecond your LED is blinking on, getting on and off and off. Here you are able to see in the written format, na? So this is called toggling. Okay, any doubt here? See,
Yes, sir.
see, these three functions are very important. Okay, but you don't need to add manually these three functions. These three functions will automatically added by the software when we will configure the peripherals. Okay, if you will not configure the clock section, then this function you will not see here. So this is very first step. In every code you will get these three lines. Any question you want to ask, or shall we move forward? Okay, no question. Okay, so this program you can practice on your by your own self after installing the STM32 software. So just copy this code and put inside the while loop and compile the code and flash the code in the microcontroller and see the GPIO pin is actually working or not. Got it? So here we have to do the configuration. So these are the configuration steps. So we do configuration in .ioc file. Okay, so what is .ioc file, IOC section? So this user interface is IOC file. Okay, got it? So what are the steps we followed during the configurations? So first of all, we will click on pin number port A, pin number 5, and we will select the output mode, and we will save the project, and we will click on the generate code. So STM32 will generate the code. Okay, so basically this section you don't need to add manually. This will be generated by the STM32 Max. Okay, understood? What you need to add, you have to write only this part. Otherwise you don't need to write anything. But I'm not saying that you don't need to write anything for all the things. This depends on the project actually. For this example LED blinking section, you don't need to change here. This will automatically be generated by the software actually. Okay, so let's see the real EV charger applications. Okay, so basically in EV charger and BMS, GPIO pins are used for contactor controlling, relay on and off, fan controlling. Okay, emergency stop detections, door switching monitoring, gun lock status detection, and LED fault indicators के लिए we can use, and buzzer control. Okay, understood? So these are the real applications of the GPIO. So you will get some understanding why we are using the GPIO pins. So GPIO pin are important for this purpose. So there are contactors, relays, fan in inside the system, emergency stop buttons inside the system. Okay, door switching logs basically. So there are the multiple things which are being controlled by the GPIO pins. So let's see the architecture here, block diagram. So you are here, you are able to understand this is power supply section. So it is giving 3.3 volt or 5 volt to the STM32 microcontroller development board. So when you will provide this 3.3 volt, your board will be in active mode. Okay, so there are multiple peripherals like GPIO, ADC, or and PMW and DMA, RCC clock, RTC, watchdog timer, and these are the communication protocols here. Okay, so here when we are configuring GPIO pin as an input, so input section, what the things you can connect as an input: push button. When you are connecting push button on the GPIO pin, then you have to set the GPIO pin as input. Limit switches, when you are connecting limit switches on the GPIO pin, then you have to make the GPIO pin as an input. Sensors, voltage current sensors, okay, temperature sensor, emergency stop, then you have to configure GPIO pin as input. Dual switches, so basically when you want to read something, then you have to configure GPIO pin as input. When you want to write something, then you have to configure GPIO pin as output. So here the GPIO pin has been configured as output, so means you are writing something. Okay, you are getting some output from the GPIO pins. So when you are configuring GPIO pin as output, so what are the things you have to connect to the GPIO pin? Relay, contactor, drivers, fan buzzers, okay, LEDs, display, gun locks, okay, contactor, cooling fan, alarm, LED indicators, gun lock, charger modules. So when you are connecting this kind of hardware, then you have to configure GPIO pin as output mode. So let's see the communication interface like PC, HMI. Okay, display, when you are connecting the display, so that you have to see the display is supporting the UART or not. So when the display is supporting the UART, then you have to connect the display on the UART peripheral. BMS, you have to use CAN module, double EEPROM, ITC, RTC sensors. So we will use ITC, I2C, and SPI can be used for the display, flash, and SD card. Okay, so suppose you have a SD card. So when you want to interface the SD card with microcontrollers, so you have to work with SPI. You should know how to work with SPI protocol. Suppose you have RTC or any sensor which is supporting I2C protocol. So the things, the modules which are supporting I2C cannot be connected on CAN or UART or SPI. Understood? And there are two kinds of memories: a double EEPROM, flash memories, and here user interface. There is a button and OLED display is given actually. So how we program? There are JTAG, through the JTAG we can program or we can flash the microcontrollers. There are two ways: SWD and JTAG. So JTAG is very important. It is highly used in the industries for flashing the code and debugging the code. So this JTAG is connecting your board, and this is flashing your code in the flash memory. This is the flash memory. This is your processor, microcontroller processor, and all the peripherals are connected to this processor in this way. Understood? Any doubt here? Any doubt? No? Okay. So guys, let's talk a little bit about the UART communication protocol. Okay, so basically this is important communication protocol. It is a simple serial communication protocol used for the communication between two devices. Okay, so it transmit the signals basically, signals from one place to another. Okay, so there are two lines which are used: RX line and TX line. So RX basically transmit data. RX is used basically, TX line is used to transmit the data, and RX line is used to receive the data. Okay, and there is another line, ground. Okay, so what are the applications of UART basically? So when you are connecting your microcontroller to the PC, then UART, this is also happen on the UART. A GSM module works on the UART, BLE module works on the UART, and ESP32 communication. Suppose you have STM32 microcontroller and you want to connect with ESP32 microcontroller, then which communication protocol you should know, or you should understand the UART. So full form of UART is universal asynchronous receiver and transmitter, and this UART is also used for the debugging purpose as well. Got it? So suppose this is your STM32 microcontroller. So this is STM32, and this is your ESP32. So there will be two pins on STM, RX and TX pin. Okay, so the here we need to understand the hardware connection between two devices. If the connections are wrong, then the devices will not work or will not communicate with each other. So suppose the TX line of STM32 will be connected on the RX line of ESP32. Okay, and RX line of STM32 will be connecting on the TX line. Understood? So this kind of connection you have to make. Now let's see this. So basically UART is making your data into the serial format. Serial, what is the serial? Serial means so here you are able to see the data. There are two formats of data. This is the parallel formats, okay, and this is the serial formats. Okay, so when you are sending in any data into the serial way, so the data will go like this: 0 1 0 1. So this way, okay, only one line will be used for transmitting all the data, and this suppose this is your transmitter line, this is your receiver line. So this line will receive data like this: 0 1 0 1. So this format, this in this way. So here, like here you are understanding now, this is the parallel. So when you are sending the data into the parallel format, then multiple pins will be required. Okay, 8 pins, it is taking 8 pins now, but here we are converting the parallel data into the serial format. Okay, only 2 pins are required. Understood? So basically this is your processor, or this is your processor part. This is processor. From the processor, the UART is taking data in the parallel format and then converting to the serial, and this section, suppose this section is receiving data into the serial format, after that converting into the parallel, and again the data, parallel data, will go into the processor. Okay, understood? So here the things has been complete. Okay, so guys, this workshop is completing here. Okay, and I think you have got proper understanding about the things whatever I have taught you, the important things. Okay, so if you want, if you are really interested, then let me know. Okay, otherwise thank you, bye. Any question? Okay, bye.
No.
Any doubt? Hello, hello.
No, sir.
Okay, so what if you are joining the courses, so what we will do, like we will do the practice more. Okay, build some mini projects, explore advanced peripherals, work on real world applications, and practice, we will practice more. And a part of it, we will also provide you some links of some startups or companies where they are asking for the freshers, embedded freshers, or having 1 year experience. So they definitely consider if you are having proper knowledge, or as per the if your knowledge is fulfilling their requirements, they will definitely take you. Okay.
Fees for this course, sir.
Yes.
Fees.
What you said?
What is the fees for this course?
Fees is around 4,500 for 3 months. Okay, so basically I'm also working in a company. Okay, so I'm not like, it is not like we are not charging too much like Emertex or some other institutes. So if you will see this, if you will figure out some other institute, they are taking 50-60,000, even there is no placement guarantee. Okay, or they are I have talked many people, like
Yes.
people from Emertex, people from Bacter, they don't know anything. Okay, after spending 50,000 rupees, because the Emertex have the institutes have lot of students, na? They will not be able to focus on you
Yes.
individually. Okay, so the most important thing is the time.